Okay, so let's get started. Welcome all to Omdena Silicon Valley chapter's tutorial on Docker. Much needed tutorial, as I heard from the people who sign up for this talk. So we'll continue to admit people as they come in. But in the meantime, I'm going to just introduce the chapter and get started. Yeah. Okay, just a little bit about myself. In case people don't know me, I am the chapter lead for the Omdena Silicon Valley chapter. People hopefully come on time. Sorry, apologize for that. I have to keep admitting people. I thought I didn't keep a waiting room, but yeah, technical difficulties always will happen. So I have over 10 years of experience, professional experience in various roles of research, compute hardware modeling and product development, and recently data science and machine learning. I am a product owner and technical lead and mentor at Omdena, and a product strategy and operations consultant at Informatica. My interest, of course, is to use data science for social impact and social good. In my free time, I like to volunteer and mentor young adults and underprivileged kids. I volunteer in my local high school and various data science organizations like Women Who Code, Women in Data Science, and I'm also an ambassador this year, and Women in AI. I have a master's of science in physics, and I did my PhD research in astrophysics. So I have a variety of background, and I enjoy wearing different hats during my professional role. So just a bit about the Silicon Valley chapter. It was established this year in May 2021. What it is it's built up off of the platform of Omdena. What is Omdena? If people are not familiar with Omdena, it is a platform where over 1,800 AI machine learning engineers from a variety of domain and levels of expertise, they come together to build innovative solutions to real-world problems. Now, these problems are a variety of problems for mostly for social impact. And we think that through innovation and more collaboration, we can democratize AI and help. And in return, what do these engineers get in return? They get to work on real world problems. They acquire relevant data science skills and work towards building or upskilling themselves in a meaningful data science and machine learning career. And what kind of projects do they do? So they solve a variety of problems for various NGOs, social enterprises, and other startups, impactful startups. And the type of topics that they tackle are very varied, and you can go and see that on their website. They can tackle climate change. They can solve problems on road safety, fight psychological abuse, take on political problems, address mental health issues, food security, PTSD, depression. So there's a whole variety of problems, slew of problems that they solve using data science and machine learnings. And to date, they have worked on over 80 plus problems. I'm going to just admit a few more people in there. So what is my chapter's mission? Is basically to promote AI education through not just case-based studies, but also technical presentations like we're having one today, and bring in experts to share the latest trends and ideas. And it is a place where we want to educate our local community and, of course, the community across the world, as many of you are from various corners of the world here today, and helping to build good solid AI that includes everybody's voice, and democratizing AI and help members to grow professionally in their career. So what are the typical things that we do in our chapter? We run projects, which are about 4 weeks long, with either local organizations, NGOs, or have an independent project ourselves. We have, while we're in a project, we will do technical workshops, tutorials, provide resources, bring in experts to upskill the team in the relevant problem that we are trying to address. And we also have brought in guests who basically inspire and share latest trends with the chapter members and the audience. So what have we done so far? Since we kicked off this year, we had an AI for Good speaker from France. She's also Caroline Lair, who's the CEO of the Good AI and co-founder of Women in AI. And she spoke on the UN's Sustainable Development Goals for 2030 and how data science can help us reach those goals. And we also had a case study of detecting anomalies on Mars with Erum Afzal. She's the AI lead and mentor at Omdena. So these are the things. So this was Erum's presentation on anomaly detection in May. In July, at the end of July, we kicked off another a 4-week challenge in my chapter where we worked on a project devising safe travel paths in the aftermath of an earthquake. We had over 50 plus data science and machine learning engineers sign up for the projects. It included deep learning, segmentation models, pathfinding algorithms. We worked on different pathfinding algorithms. We worked off of satellite images, OSM, OpenStreetMaps, and much, much more. And we built this challenge on a previous Omdena challenge, but we picked a different area. We picked the area of Los Angeles to, as you know, that it's prone to earthquakes. This region is prone to earthquakes. So we picked that region in order to make a case study. And we also have some articles on this case study that we did. During the work 4-week workshop, we also had a tutorial on OpenStreetMap given by Emma Roscoe to kind of upskill and educate the participants in OpenStreetMap. So these are the kind of things that we do in our chapter. We try to bring in opportunities where people can upskill on a new technique or a new tool that they would need in order to complete a project. So sorry, I'm just trying to admit more people in if they are there. So like what we are going to have today. So let me start introducing today's speaker. And this is a much awaited tutorial. What I understood from talking to people who wanted to attend, who wanted to participate in the chapter. I will introduce you to Vinzent Steinberg, who's a PhD candidate in computational physics, and he's a long-term software developer as well. He's been in this role for more than 12 years. He has contributed to open source projects in multiple programming languages such as SymPy, the RAND library, and Smash application for particle physics. I think he has a background in computational physics. Vinzent also has dedicated his free time to the data science community for good, and he's a technical mentor and a lead machine engineer at Omdena, helping teams to bring their projects to deployment. So just briefly about what the tutorial is about today, right? I'm assuming that most of the audience here has written some code. And how many times have you come across a situation where the code you have developed has worked on your machine, but did not when somebody else ran it on their machine, or does not work as expected in production, right? This is a very good, a neat cartoon I found on LinkedIn, and I thought I'd present it to the team here as it was very relevant to our talk today. And then, and why would not it work on somebody else's computer or in production is it could be due to various dependencies, libraries, operating system versions that you're using, microservices that you have in play. So what Docker does, it enables developers to easily pack, ship, and run any application, what its dependencies, in a very portable, self-sufficient container, which can run virtually everywhere, right? Containers, they give you an instant application portability. Another reason why containers are popular is they lend themselves to DevOps, right? Most of us have heard about CI/CD, continuous integration and continuous development. So what it does is encourages developers to integrate their code into a shared repository early and often, and then deploy the code very quickly and efficiently. Dockers essentially run on any operating system or cloud. They're very versatile. And as data scientists, it becomes almost mandatory to know how to use Docker. And knowing maybe you don't want to be an expert in Docker, but knowing a little basics about this very essential tool will put you in a very advantageous position. So today you'll learn about what Docker is and how to build your first container. Vinzent is going to take us through that. What I'm going to do now is I'm going to hand you over to Vinzent, who's going to introduce you and take you through when and how to use Docker. He has also included a hands-on part where you will learn how to build Docker containers from a simple Python app and all the way to TensorFlow deployment. So without much ado, I'm going to hand it over to Vinzent, and let's get started. So Vinzent, you're on. Let me stop sharing my screen.
Thank you so much, Nishrin, for this nice introduction and for the opportunity to let me speak here. I'll just share my screen. Okay. All right, so yeah, I'm very happy to see so many familiar faces here and so many people participating. And my plan is basically for approximately the next hour to give you an introduction into Docker, and also including some hands-on parts where I show you how that would look like if you run it on your own computer. If you want, and if you already installed Docker, you can try to follow along with those commands and run it directly on your own computer. If not, you can also do that later. I try to make sure that from the slides it's clear more or less that you understand what you have to do, even if you look at it later. Okay, so let's maybe again start with a motivating example. So Nishrin already gave you one with the cartoon she shared. And so the basic idea is that, let's say you're a data scientist, you created your model, it works flawlessly, the accuracy is very nice, and it's very efficient and so on. And now you really want to share your code with your colleagues. So basically, you have your model and you give it to the others. But unfortunately, there are some problems. So your first colleague says, okay, I tried to run your model on my computer, but it didn't work. And of course, this can have many different reasons. But I'm sure that any of us was in this situation at one point, either that you were the one who tried to share and it didn't work on the other computer, or someone tried to share their code with you and it didn't work on yours. You could also have like similar problems, like, for example, the second colleague you wanted to share with says, okay, I tried to install all the dependencies, but like when I tried to install the version of TensorFlow that I need to run your model, there was some problem and I couldn't install it. Or one of of your other colleagues actually already tried to deploy your model to the cloud, and then there was also some problem that, okay, maybe it even ran on his computer, on their computer, but when they tried to deploy it to the cloud, it didn't work anymore. And all of those problems are very common, so that happens to everyone, and that's normal. And I think any of us can solve those problems if they invest enough time for it. But wouldn't it be nice if you wouldn't need to spend so much time on figuring out how to recreate the correct environment for the model so everything works, and could instead focus on your actual work, which is doing data science? And this is kind of the motivation for Docker. So let's look into more detail what Docker actually is and how it can help us solve these problems that the data scientists I showed you on the previous slides had. So Docker is a tool to deliver software in containers. Containers are, if you can think of it as like the environment in which your application runs, including your application. And they are isolated from each other, which means that each of the containers bundles their own software that they need, including all libraries and configuration files. If you want to think of an example, let's say you want to run some Python app, then that would mean that your container includes exactly the Python version you need, including all the dependencies, like exactly the pandas version you need or the TensorFlow version you need, and all other dependencies that you need to run your software. And it's important that the containers are isolated from each other, because that means if you, for some reason, have two different apps and they need different versions of the same library, they will not interfere with each other, because each app basically has their own container with all their dependency exactly as they need it. Additionally, the communication between the containers is only possible via explicitly defined channels. And that is also important because it makes it sure that everything is explicitly configured, so that if, for example, you have two containers that contain apps that need to talk to each other, that means that you have to explicitly define how they are supposed to communicate. And while that seems to be like a bit of more work upfront, it also means that it's clear what is necessary for them to talk to each other. And it makes it easier to basically for someone else to reconstruct the environment where those applications can actually talk to each other. So Docker doesn't just help you deploying one app, it helps you to deploy lots of apps that have to talk to each other. The tool itself was created in 2013, so it's quite established by now, almost 10 years old, by the Docker Incorporated company. And it is implemented using lots of Linux virtualization features. I don't want to go into detail what they are, but it's important to keep in mind that fundamentally Docker is a Linux-based technology. So to give you an example how it works technically, there's this picture you can see on the right here. And if you look at the bottom layer, we have the hardware infrastructure. And on top of this hardware infrastructure, you would have the host operating system running. This could be Linux, it could be Windows, it could be Mac OS. And on top of this operating system, you have the Docker application, or sometimes also called Daemon, running. And this Docker application basically then takes care of running the different containers for the different apps. So you can see there are apps A to F, and each of those apps has their own container that has like all the requirements they need inside this container available to them. And yeah, that's basically what Docker is doing. It's kind of providing those isolated environments for your applications. Yeah, and then why would you use that? So the big promise of Docker is that you basically build your container once, and then you can run it anywhere, including your laptop, your colleague's laptop, or in the cloud, or your other laptop. So that's like a very powerful promise, and that's the reason why Docker is so popular and successful. You can also share sorry, your Docker containers with a community. And you can also profit from the community because they are sharing their Docker containers with you. That's very useful. For example, if you want to deploy a TensorFlow or Python app, you can actually get an official Docker container that already has everything you need to build such an app. And that can save you a lot of time, especially if you have something that can be very complicated to set up. Like, for example, I'm sure many of us had like problems setting up TensorFlow. I know I spent a few hours with that. And if you just can use the official Docker image, you can basically avoid those kind of problems. And additionally, I mentioned earlier, even if you have several applications that need different versions of a framework that are incompatible to each other, you can avoid those conflicts using Docker because each application has their own environment, and that makes sure basically that even if, let's say, one application needs like a very old version of pandas and then the other one needs the most recent one, and they are not compatible to each other, those two different pandas versions, even then you can still solve this problem essentially just by putting the two applications into different Docker containers. And of course, the same also applies to any kind of frameworks, libraries, and even languages that you can think of. Like all this is basically also solved by Docker. Okay. If there are any questions, please feel free to use the raise hand feature of Zoom. I'll try to keep an eye out. So if anyone raises their hand, I can address it. So please feel free to do that. And you can also, of course, type in the chat. If you have any question about this part so far, then please feel free to do any of those things I just suggested. With that being said, let's continue. So I think some of you already installed Docker successfully. If you didn't, or if you ran into problems while doing that, I'll just comment a bit on what you need to do to set it up. So if you're using Linux as your operating system, you're lucky because then it's very easy to install Docker, because in basically every Linux distribution, Docker is already included. So you can just install it with your package manager and that's it. If you use some other operating system like Windows or Mac OS, the recommended way to install Docker is to install Docker Desktop, which includes the Docker daemon itself and also some additional graphical user interface, like you can see here in the picture, like that can be nicer to use than having to use the terminal in some cases. However, just so you know, since August this year, the professional use of Docker Desktop in large organizations, which means organizations that have at least $10 million of annual revenue or more than 250 employees, require to have a paid Docker subscription. Docker itself is free and open source, but this graphical user interface called Docker Desktop is not. If this is for some reason a problem for you, there are alternatives. For example, there's a Rancher Desktop that you can try out. I didn't try that out myself yet. So what I'm assuming for today is basically that you're using Docker Desktop. But just so you know, there's alternatives where even if like somehow this requirement here is a problem, you can work around easily. And those alternatives are mostly compatible with what you will learn today. Okay, and then I want to spend a little bit of time mentioning Windows because I know that a lot of you use that. And it's a bit more tricky to install Docker there. So I see some questions in the chat. Yeah, the presentation can be shared. I can even give you the link right now. Or maybe Rosanna can share the link actually, because that's maybe easier. Yeah, so if you install Docker on Windows, you basically have to do a bit of additional work because Docker requires Linux somehow. Luckily for us, Windows includes a subsystem for Linux called WSL. And that is basically provided by Microsoft. It's part of Windows and it lets you run a small Linux on your Windows system. And nowadays it's also very easy to install this subsystem. So you basically just have to go to a Windows terminal or a PowerShell terminal and run this command here, WSL -- install. And if you need more details, then you can find that on this link here in the presentation and the official Microsoft documentation. And then Docker, if you install Docker Desktop after you install WSL, it will recognize that you installed the WSL, and it's also strongly recommended that you use the WSL as a backend. There's also an older Hyper-V double backend, but this is a bit outdated, and it's also more tricky to use because it has stronger hardware requirements. And I think you also need Windows 10 Pro for that. So WSL does not have these limitations, and it's also more modern. So I strongly recommend you to use that. And that's also what I will be assuming for today, basically, that you're using the WSL backend. One caveat that affects us, unfortunately, because for machine learning, often you want to use your GPU if you have one, just to make training faster, or in some cases even feasible at all. And then that means that you need Docker to be able to use your GPU. On Linux, this is not really a problem, but on Windows it is, because that means that the little Linux that runs inside of your Windows needs to have access to the GPU. And unfortunately, this is kind of still experimental technology, if you want. And that means you have to do quite some involved steps to install Docker with GPU support on Windows. It is possible. I can show you if you want later, but it's a bit complicated. And if there's interest and we have enough time, then we can have a look at that at the end, and I can give you some tips for that. But yeah, for now, I'll just want to focus more on the important basics of Docker. Okay. Then let's go further. So if you're using Docker, they are using some kind of terminology that is specifically to Docker. And this slide is basically for explaining what this terminology is. So we talked before about containers. And then, of course, the question is, what is a container? And then there's also so-called images or container images that are also important, and Docker files. And they all are connected. So basically, you can think of a container as an app running on your computer, including all the environment that this application needs and that is defined by Docker. So it's basically a process that is isolated from all other processes on your host machine where you're running Docker. So yeah, you can think of this like as your database or your Jupyter notebook running on your computer. And to get a container, you need a container image. So basically, an image is all the data you need to create a container. So this means that, for example, this includes an isolated file system that has all the dependencies, configuration files, scripts, binaries, and whatever kind of file you need to run your application. Could, for example, also be some kind of database or some CSV files or whatever you need. And it also includes some instructions for creating a container. So, for example, what commands do I need to run for starting my application? Maybe I need to set up some environment variables and so on. And it also includes some kind of metadata that helps you a bit describing basically what your application does and what it needs. And this is all very important, to make sure that the environment is set up correctly, and that basically if you want to share your Docker container with someone else, that they can also run your application. So that this is kind of the crucial part of Docker. And the way you define such a Docker image is by creating a Dockerfile. That is essentially a recipe for building a container image. So you can think of it as an instruction manual. We will look at this in a minute. So maybe just to give you an example, let's say you want to run some TensorFlow Jupyter notebook in a Docker container. Then you would first create an image that basically tells Docker to, okay, I need Jupyter, I need Python, I need TensorFlow, please install all that. And then once you're done with it, then run the Jupyter command to open my notebook that I provided as a Jupyter notebook file, like this .ipynb file that you know from using Jupyter. And basically all this is part of the image. And you can basically tell Docker, okay, here's my Docker file that tells you how to build this image. And then Docker will create the image, download all the files and software it needs and so on, and then have this finalized image. And then you can use another Docker command to run this image, which will basically start the Jupyter and the Python kernel and so on, and lets you access the Jupyter notebook from your browser. And yeah, so you can think of the container image as it's similar to kind of like if you have like a normal software project, this would be kind of your binary files or your script files. And the container would be then what you get if you run those binary files or if you execute the script with the Python interpreter. Okay, and if you want to create a Dockerfile, the easiest way to do that is to start with one that was already built for you. And you can find all those Docker files that are shared by the community on a website called Dockerhub. So let's maybe have a look there. So here, this is just a link to Dockerhub. I'll open it. And then you will see here that there you get this Dockerhub website. And now let's say we want to install like some Python. If you want to build a Python application that runs inside a Docker container. And then we search for Python here. And as you can see, the first result is the official Python image. So if you click on that, then it will you will basically see here that you have some information, like you can see there's lots of different Python versions that you can use and so on. And then it explains a bit about Python, and there's a README file. And here it basically shows you how to use this. So you have like an example here for a Dockerfile for running your Python app. And this Dockerfile here uses this image that is shared on the Docker Hub. And what we're going to do now is to basically have a look at this file in a bit more detail. And I'll explain to you what the different parts mean of this Dockerfile. Okay, so before that, maybe to clarify how Docker works and a bit what the role of the image and the container is, let's look at this picture I put here, a bit larger. So now if you look at this here, it gives you a bit of a summary of the Docker architecture. So here is the client. That's basically the computer in front of which you are sitting and that you are using to interact with Docker. You can do that via a terminal. You can also do that via some remote API, or that, for example, is integrated into some text editors. For example, Visual Studio Code, if you're using that editor, it has a very nice Docker plugin that you can use. And you can use that to help you to interact with the Docker daemon. And what is the Docker daemon? Daemon is just a term from Unix, basically, for some kind of application that runs in the background. And in this case, that's Docker. and it runs on the host system, which in my case, for example, today will be on the computer I'm using right now, but in principle that could be also some other computer somewhere in the cloud. And basically, as I said, you interact with this daemon by running some commands that we will see a bit later. And then the daemon manages all things Docker for you. So for example, you can tell the daemon, okay, I want to have please get me this image for Python from the registry, which is the Docker Hub that I just showed you. And then it will download this onto your computer. And then you can tell the daemon also, okay, now that you got this image, please use this image to build a container for me where I can run Python. And then Docker will basically take this image here and create a container. And of course, from one image, you can create as many containers as you want. So let's say if you need, for some reason, 3 different Python containers, you can just run this image 3 times, and then you will have 3 containers that you can use. And yeah, this is kind of how Docker works. It also does things if you want to push like your image to the registry on Docker. That's also possible if you create an account there, and some other things. But the basic idea is that this is basically what Docker does for you. It helps you to interact with the images and to create containers from them. And if this is a bit abstract, we will look at this in more detail later after we understand how the Dockerfile works. And then I will show you on my computer how to use all this to create a Python app that runs in a Docker container. Okay, so if you have any questions, again, let me know. Otherwise, I will just look at this file here in more detail. So if you want to use this file and copy and paste it to your computer, you can either try to copy and paste it directly, or you can follow those links I put here in the presentation. So let's, for example, if you click here on the Dockerfile, it will open here like this as something that you can easily copy and paste to your computer if you want, or download or whatever. And the same for the other files here that are used, but we will look at them in more detail in the hands-on part. Okay, so as you can see, it's just a text file that has a few keywords at the beginning of each line. And let's try to understand what those keywords mean. So the first line, from Python 3. So this basically tells Docker what base image it should use. And in this case, it will pull a base image from the Docker Hub. So here it tells it basically, please use the official Python image. And then there's this colon that separates it from a version. So this tells Docker, I want to have the official Python base image from Docker Hub. And I want to have Python version 3. If you need, for some reason, a very specific Python version, for example, let's say for some reason your app doesn't work with Python 3.9, then you could say, I want to have Python 3.8. And then Docker will get exactly the Python version that you specify here. In this case, of course, it will get the most recent Python version. So you should make sure that Docker works, that your application works with the most recent Python version if you are using this here. Okay, then the next line tells you the workdir keyword tells Docker what working directory it should be using inside the container. And here it's important to understand that this is a directory that is not on your host operating system. It's really inside the Docker container. So this is a Unix path. And as I said before, Docker is based on Linux. So inside the Docker container is always a Linux system. Even if you use this Dockerfile on Windows, this doesn't change. You have to use this Linux path because it's a path inside Docker, not outside. And this is basically just the working directory where your application will be started. And whenever you, for example, create a file from inside of your application, it will be created in this directory inside the Docker container. And there's also a lot of other directories that are part of the Docker container that are essentially part of the Linux system that is required to run the Python. And this is where you define, this is the directory for my application. And okay. Then the next part is Python specific. So copy is a command that tells Docker to copy a file from the source folder where you define your Dockerfile into the Docker container. So basically, here this command says, okay, I have in my source folder, there's a requirements.txt file. Please copy it directly into the Docker container. And in Python, as you may know, the requirements.txt file typically is used to define what other Python packages your Python application depends on. So let's say if your Python application needs pandas and maybe NumPy and SciPy and matplotlib or whatever, then you would put all those requirements inside this requirements.txt file. And then the next step is to run a command, which is this, as you know from using Python, pip install. And it basically tells pip to install all the requirements from this txt file. And then there's also this flag here, no cached here. This is just specific to Docker if you want. Normally, if you install a package and download it with a pip, it will be stored in some folder. So in case you don't need to download that package later again, it doesn't have to download it twice, but it will just access the package from this directory. But for Docker, this doesn't make sense because the caching is basically already done by Docker, as I will explain later. So it's important to remove this just to save some space that would be wasted otherwise. Okay, and then the next command is basically to copy everything from your source folder into the container. And now this might be a bit funny because why do we copy everything now, which actually includes this requirements.txt file? Why didn't we just copy everything before if we need everything anyway? And so you could also basically, if you want, you could just, instead of copy requirements.txt, you could just say copy dot, and then everything would be copied, including the requirements.txt file. And it would work, and there's not really a problem with that. The reason why we do that is because Docker does some caching strategy, if you want, that is basically that whenever you have one of those Docker instructions here, it creates a new layer. So you can think of it like an onion. So for example, here, this from Python 3 command means that the innermost part of our onion will be like a Python 3, like a Linux system that includes Python. And then if you copy the requirements.txt, you will have a Linux system that includes Python 3 and this one file. Then you run the pip install, and then you will have a system that includes Python and all those packages that you installed here, and so on. And this is important for caching because basically when Python, when Docker, when you build the image later, and then it has to do all those steps, right? But if, let's say, there's already an existing image that you built, and you only changed your source code of your application, but you didn't change the version of Python you need, or the Python packages you need to install, and so on, then it would be nice if Docker wouldn't just blindly follow those instructions and reinstall Python into the container, reinstall all the packages, which can take a very long time in some cases. But it would be much nicer if Docker would only do the things that are new. And this is why this is important, because if Docker always goes basically, looks what changed if you build a new container again, and it will basically only rerun the commands that are necessary to get to the stage where you are. For example, let's say here, when you copy all of your source files into the Docker image, then if you change one source file, it knows, okay, this command has to be run again. And I also have to run the command that all commands that come after this command, but I don't need to rerun the commands before this. And then basically, if you think of it as an onion, it only has to unpeel the outermost layers, which is your source files. And it doesn't have to redo all the inner parts of the onions, which is like installing Python, installing the requirements, and so on. And for this, it's very important that you first only copy the requirements.txt file, and then you copy all the rest. Because otherwise, if you copied everything here, it would mean that even if you only change your source file in your app, it would still have to reinstall all the requirements. Because Docker is not very clever. It only looks basically which files you are putting there. And if any of those files you're putting there are modified, it has to rerun the whole command. Yeah, so this is, if you want, this is some kind of optimization that plays nicely with the Docker cache. If this was a bit confusing, that's okay. This is not super important. It's just, yeah, I just wanted to try to explain why they are doing this in this a bit weird way. It's essentially just so that if you change your application and you don't change your requirements, then Docker only basically has to copy your application again, but it doesn't have to reinstall all those requirements. And that's it. Okay. So that was a bit long. So the next command, fortunately, is much simpler. So this is the final command, which essentially only tells Docker to run how to start your application. And for a simple Python application, it would be just this command here, as you would use on your terminal. If you want to run a Jupyter notebook, you would, instead of Python, you would use the Jupyter command. And if you have, I don't know, some kind of arguments that your application needs and so on, then you would also put them here. We will look at this again in an example in the next step. Okay. Yeah, again, as Rosanna just said, if you have any questions, please feel free to raise your hand or to ask in the chat. So I will now, basically look into running some examples for this. So, okay. So here, like the commands that I will use, I'll just copy them into the chat. So even if you don't see my screen, you know what the commands are that I'm using. And as I said earlier, we have to run two commands. One is for building the image, and the second one is for running the image. Okay, so let's just create a folder. And now we just need to create this Docker file that I showed you earlier. So I will just go basically to this link here that I think Rosanna also posted in the chat for the Docker file. And I just copy and paste all of this. And I will create a file called Dockerfile inside my folder and just copy and paste this here. Yeah, this is the file we just looked at. Okay, then in this case, I need two more files. So if you look at the Docker file, maybe let me just open it again. You will see here that we need a requirements.txt file. And we need a app.py file. So we still need to read those two files. Okay, so there's a question in the chat. Let me see. Okay, I'm here using the Windows terminal. That's like an application you can install from Microsoft, but you can also use the normal CMD terminal that works exactly the same. And you can probably also use the PowerShell. Yeah, either should work, and you need to use some kind of text editor. So in this case, I'm using like a Unix text editor that is part of the system that you install for running Git on Windows, but you can use any text editor in shell. What folder? Okay, so the folder I'm in is like, in this case, is just some folder in my user folder on Windows that I just created, like this Docker example folder. And yeah, and this CLI, this is like the, something that provides some Linux commands, but we can also use, you can also use here like exactly the Windows command prompt. You just have to use a different editor if you didn't install VI on your computer. And I think creating directories also works like this on Windows. Change directory also is the same. Okay. Okay. I just like to use this terminal because it's easier to make the text bigger. Yeah, and that's a bit easier to see on the screen if I share it. Okay, especially if you're watching from a phone or something. Okay, so I said we need a requirements.txt file. In this case, I will just create an empty one. Because let's assume we don't have any dependencies. And we need an application. So for this, I'll just use hello world. So print hello world. Yeah, just the simplest Python application imaginable. And now if I look at this ls, and you would use it on Windows, you would use dir, but that works too for me actually. Then you can see there's those 3 files. Like the Dockerfile we looked at in the slides, the hello world application, and the requirements.txt that is empty. Yeah. And yeah, those are all files that I need. And then I can just use the commands I posted. Okay, there's another question. In Visual Studio Code, yeah, you can just use the Visual Studio Code terminal. That's no problem. You can use any terminal you want. It's yeah, basically whatever you prefer. Okay, then let's just copy and paste this command from the first command from the chat. So this command uses the Docker daemon, and it tells Docker to build an image. And then we use this -t here, and the -t tells you what the name should be of this image. This is called tag. It could also, for example, be which version of your app that is, but it's whatever you choose it to be. And if you don't specify a tag, then Docker will create one automatically for you, which is also okay, but we need it later, so that, that's why we're choosing one here. And yeah, then you basically just run this command. And Docker will now execute everything that is written in the Dockerfile and download all it needs, install everything with pip, and so on. And in my case, it finished rather quickly, which is because I did this before, and then Docker reuses the packages and Python base images and so on. It downloaded before. Yeah, so that's why it will take a bit longer on your system, because it will first have to download the Linux system with a Python, and so. Okay, so this is something you can also try to run. And now we can use the second command I posted in the chat to run the Docker container. To basically create a run basically creates a Docker container from the Docker image. And here we are only telling it -i for basically that it's interactive and running on the terminal. And the t is again the tag of that we used before here, like when running the first command. That's just the name of our Docker container. And if you do that, then you can see, okay, Docker just executes this hello world program inside the Docker container. And yeah, this is it now, of course, not very interesting. So it would be, for example, more interesting if we use some Python package. Let's say we want to use requests, like one of the most popular Python packages that is used for downloading things from the internet. So you would just go to your requirements.txt file with your favorite text editor, and you can just put requests here. Oops, requests. That's the name of the library. Okay, there are questions. Let me have a look at the chat. Yeah, okay. The message you're seeing there is correct, Matteo. You're a bit quicker than me. We'll get to that in a second. That is exactly what you should be seeing. So very good. Okay, so if you want to use requests, just to give you an idea what this library does. Requests, Python. Can just look at the documentation. There's already some example here. So you can basically use this get, create an HTTP GET request. And here, as an example, they use GitHub. So maybe let's just try to do something like that too. So can just copy. In our case, because I don't want to deal with authentication, I will just basically use it without that. So let's just change our Hello World example app to use something from request. So import requests. And then we say, okay, please try to get this request from GitHub. And instead of hello world, we will print the GitHub response as a JSON. So r.json, which is also taken from this example here from the website here, like the last one, yeah. And yeah, because I don't want to use my password like this, of course. So that's why I just try to do the simple example here. And the difference now is that Docker will have to correctly install the requests library into the image, and then we will need to see whether this works. So let's now try to run Docker again. Sorry, that was wrong. I need to. So if you run it again now, you will see that it's still hello world. That means that's normal, because you have to keep in mind your application in your folder, in your source folder, and your application in your image are different. They are not the same. So you basically have to build the image again so you can run it. So that means we have to run the Docker build again. And now it will reuse everything from before. So for example, it will not download Python again, but now it has to install the requests library, which in my case is very quick because I already installed it earlier today when I was testing this, but it might take a bit longer for you. Okay, and then hopefully now if I run it, it should work. Yeah, and that is what I wanted to see. So you can see now that as was posted in the chat by someone who tried to run this before, here the message, you get a JSON response from this HTTP request to GitHub, to the GitHub API. And it basically tells you message requires authentication. And that, of course, makes a lot of sense because we didn't provide any authentication. We didn't give it a username or a password, so we get an error. So this is exactly what you would expect to see from this simple example. Okay. If you want to run the step, you can use this link here from the the requirements.txt file and the app.py file that I used for this. They are also part of the presentation. And this is basically, if you want to reproduce what I just did, you can just download those files and run those commands, and you should hopefully get the same result. Okay, now let's look at questions. So Indu is asking, how does the Docker setup differ from setting up a YAML with a Conda environment for sharing purposes? And that is a good question. So there is indeed some overlap between Conda and YAML. Sorry, YAML, Conda and Docker. So what Conda does is it lets you not also define what Python version exactly you want. And then Conda will install that Python version for you and manage it. Docker goes a bit farther. It doesn't do that for just Python. It does it for any software. And that's especially important if you need some software that is not part of the Python ecosystem. For example, if you need some geoparsing library that is written in Java, then Conda will not help you, because Conda only manages Python packages. And for cases like that, you need something like Docker. And yeah, this is actually also something that happened in a project, in a machine learning project I worked on, that we needed like some geoparsing, and the best library we could find for that was written in Java. And then we also were using Docker, and that would not be possible with Conda. And also the isolation that Docker provides is a bit stronger than what Conda does. So if you want, Docker goes a bit farther than Conda and can replace Conda. It has also some disadvantages. We can talk about that in more detail later, but basically Docker is not just for Python, it's for any software. Okay. Okay. How do we share the container? So the container, in most cases, if you want to collaborate with your colleagues, you don't have to share the container. It's enough to just give them the Dockerfile. So let's say you're using Git to develop a project together. Then you would just put the Dockerfile into your Git repository. And anyone who clones the Git repository can just run the Docker commands. And ideally, everything should just work if your Dockerfile and so on is correctly configured, and all the other files that are needed are inside your Git repository. So that's what I would recommend for most cases. You can also share your Docker images on the Docker Hub. That's also possible. If you want to know how to do that, you can look at the official Docker tutorial. It's explained there. This is, however, not something that is super necessary for collaborating. It's more important if you want to share it with others. For example, let's say you are working on some machine learning library and you want to make it easier for other people to build Docker containers using your machine learning library. So, for example, if you're like a TensorFlow developer, then you would publish an official Docker image for TensorFlow on the Docker Hub. But that's not really needed if you just want to collaborate with your colleagues. Yeah, so everyone needs to have Docker installed on their system. So if you share it with someone, they have to have Docker installed. That's the requirement. Docker takes care of all the rest, but you have to install Docker itself manually. And yeah, then that should work. Okay, then another question is, can you develop models with Docker workflow, or is this just for deployment? So you can also use Docker for development. This is actually something that is very nice. For example, just to give you a personal anecdote that I experienced, I was having some problems to install TensorFlow, like a specific TensorFlow version on my computer in my Python environment. And then what I did instead was just building a Docker container and developing inside the Docker container, because that was a lot easier than trying to figure out what the problem is with my Python environment. And it was much easier to just use the official TensorFlow Docker image and use that for development. And with the commands I showed you today, like the Docker build and the Docker run, it's a bit awkward to do development because you always have to if you want to run your app, you have to run Docker build first, and that might take a while and so on. But there are ways to make this experience more pleasant. They are explained in the official Docker tutorial that I will share at the end of today's tutorial. But this is a bit out of the scope of today. But there's also a very nice, for example, if you're using Visual Studio Code, there's a very nice extension that helps you to develop inside the Docker container. Okay, and then maybe to clarify, when you run those commands here, it's very, very important that you're inside the folder where you have the Docker file. So if you go back here to the Docker build, I put here the dot, and the dot is short for the current folder. So this command only works, the build command only works if you're inside the folder where you also have the Docker file. Yeah, so just to clarify here, the Docker file must be inside the folder where I currently am. Otherwise, you would have to tell the Docker build command where the Docker file is. Yeah. For the Docker run, it's not important where you are, because you're using this tag. And the tag is stored by Docker, and it's independent of the folder. So I can even show you if you want. If I go to Docker desktop, I have to just move around my windows a bit. Oops, that's not where I wanted. If I go to the Docker desktop, which is here like this icon, which is some graphical user interface, and it's very nice to see what is going on. For example, here you can see that Docker ran several containers. And by default, containers are not deleted after they exited, so you can continue running them. So you don't lose, if there's any state of your application, you don't lose it, you can continue running it. But of course, it will take some storage, and you might want to delete it to save the storage. And you can also look at the images, and then you will see here basically like all the images I built on my machine, what their tags are or names, and how much storage they need. So that's something you can look at. And if you need, you have to be careful with Docker, because if you just use a lot of Docker, at some point you might run out of storage and you might have to clean up a bit. And yeah, you can do that here in Docker desktop. You can also do that with the Docker command line, but I'm not going to show that today. Okay.
I just want to take a pause here and ask Vinzent, how long do you still have to go? I just want to be aware of people's time and make sure.
Yeah, sure. So what I was planning for today was to go to, I mean, I have like a small modification where I can show what you have to do if you want to run a web app with Docker, but we can skip that. And then the final example would be just how to run a TensorFlow app. And,
so, yeah, why don't you go over that so we can wrap it up in the next 10 to 15 minutes?
Okay, yeah. Sure. Yeah, then I'll let me do that. So let's go back to our slides. Present. We already saw that. Yeah, so just a small remark. I won't show that out of time reasons, but if you have an app that uses ports, for example, like some kind of HTTP server, then you need to explicitly tell Docker to forward those ports. And you do this using this -p flag. And here, for example, you tell Docker, if you have a port inside the container with the number 8000, forward to the port outside of the container on my host operating system with a number 8000 as well. And if you want to try this out, you can just basically download this Dockerfile I put here in the slides and run the same commands as before, like Docker build and Docker run, except that now for Docker run, you have to use this command here with a -p 8000:8000. And then you should basically run the default built-in Python server and see that, yeah, and be able to access it from your web browser. Okay, I won't show that out of time reasons, because I still want to go to a more machine learning oriented example. So let's say we want to build a Docker image for a TensorFlow app. In our case, we will just use the famous mlist classifier data set of the digits and build a neural network with TensorFlow. The code here is basically just taken from the TensorFlow tutorial. And I'm also using the official TensorFlow Docker image. Otherwise, it is identical to what we did before. So let's just look at the code. So here, this is just from the TensorFlow tutorial, just a simple neural network. I'll just copy and paste this into our file. App.py. And I'll just replace all this code with this TensorFlow code. And in this case, instead of installing the TensorFlow image with pip via the requirements.txt, we will instead use the official TensorFlow Docker image. So if you go to the Docker Hub again, you can just look for TensorFlow. And then you have to scroll down a bit to find the official image. Here, that's the official one. And it basically tells you here how the name is. It's TensorFlow/TensorFlow. So in this case, we will just go again back to our Dockerfile. I need to probably move this here so you can see. And the only thing we have to change is like here, this base image. Instead of Python 3, we'll now use the TensorFlow image. And this also includes Python already. So we are fine. If you look at this here, there's also lots of other versions. For example, if you need GPU support, there's like different images for that. Here, GPU. There, if you want a Jupyter notebook, there's also like an image for that. So you have to use the corresponding tags. And there's, of course, different versions and so on. So you can get exactly what you need. In this case, we are just using the default, okay? And so I only changed like this for the first line here, that we are using TensorFlow instead of Python. And oops, I need to write. And I changed the app to be a TensorFlow app. Yeah, like this this neural network. And now let's build the image again. You can so in this case, let's call it my TF app. So now it will install the images. For me, it's very fast because everything is cached, but for you, this may take a while depending on the speed of your internet, because the TensorFlow image, I think that TensorFlow image, I think, is about 2 GB big. So that might take some time to download. Okay, and then now we can just use the same command as before to run, except now we have to use the different tag, TF app. And then hopefully it should be now training the model and give us some hopefully okay accuracy. Because my terminal is too small. Oops. Oh, sorry. Yeah, now it's better. Yeah, and epoch 4 out of 5, it's almost done. And now the final epoch. Yeah, and here it tells you, okay, it trained a classifier neural network with an accuracy of 98%. So that's pretty nice, and more or less what we would expect. And the nice thing is now that basically Docker takes care of installing everything for you, and you can now just share this your source code with the Dockerfile with a colleague, and then they will be able to very easily run your model. Okay, that's the last part of the hands-on part. And with that, yeah, just to summarize, the only thing we changed is the app.py file that you can get here on the slides if you want, and the first line of the Dockerfile. Otherwise, it's completely identical to the Python app from before. Okay, so with that, I'm coming to the end of my slides. So if you want to continue with Docker, I can recommend the official Docker tutorial. It's not very complicated, it just takes a few hours to go through. It includes the things we did today and additionally some more things. For example, you will learn about container volumes that let you store data on the host file system. And that can also help for development. And it will tell you how to publish your image on Docker Hub. That was also, I think, a question earlier today. It will tell you how to use bind mounts for development. Then you don't always have to do this Docker build and Docker run. It's a bit more convenient if you do that and faster. It will tell you about Docker Compose, which is what you can use if you have some applications where you need several Docker containers. So for example, it's usually you have one container per application. So if you have some SQL database, it would be inside a separate Docker container. And then you need to run it together with your app. Then you can use Docker Compose for that. Yeah, it tells you about how to scan your Docker container for security vulnerabilities. And as you can see, this goes a bit more into depth than we did today. And another topic that is also very important is container orchestration. And the idea is basically you can use those containers to run applications in production. And if you want to run something in production, it's different from development because you might want to run a lot of Docker containers in parallel on several different machines just to deal with the load. For example, if you are like running your web service with Docker containers, you want to have some scaling. Like if there's lots of users, it should run a lot of containers in parallel. If there's less users, it should run less containers. And then you also need to deal with problems. For example, Docker containers can die, like because your application crashes or your hardware has a fault, or your for example, the disk of the machine breaks, and then you basically have to somehow deal with that. And those are all concerns from production and not really from development, but there's this specific container orchestration software for that. The most popular one is Kubernetes, that is developed by Google. But there are also some others like Docker Swarm or Nomad. And all of them, basically, they help you to run things in production. That's for development, that's not really necessary. But if you want to run your machine learning model in production or some other software, this is like very, very essential and important. And yeah, so this is really something, if you want to go in the direction of DevOps or MLOps, then it's important to also look into those things. And my final comment for today is that there are alternatives to Docker. So Docker is the most popular container solution, but there are also some alternatives. And I put here a link to some blog posts that compares 10 of those alternatives. If you want to know a bit more about what else there is. Okay, and with that, I would like to thank you all for coming and for giving me your attention. And yeah, please let me know if you have any questions or comments. But that would be all from my side.
All right. Thank you so much, Vincent. I think this was a super useful tutorial to have. And, you know, this is just basic fundamentals. There's a lot more depth, as he just mentioned. There's orchestration, there is alternatives, and there is more complexity to Docker as well. But this was such an amazing overview. Thank you for that, Vincent. And I think this is a very essential toolkit for all data scientists to have. And getting started was great. You made the first step in getting here and getting this tool under your belt. So, and thank you all for being here. We will share the link of the recording and Vincent's presentation as well. So look forward to an email from us sharing this, and hope to see you. We hope to bring more tutorials like this in my chapter. I know there was Kubernetes also scheduled, and we couldn't schedule because the speaker had to back out due to personal reasons, but that is on my list to get a tutorial for this chapter. So we will be working on that. And anyways, it would have been too much to ingest everything together. So having a little bit of a break between the two would give you more time to assimilate what Docker is all about, and then move on to the orchestration part. So so look forward to future more tutorials on Kubernetes and other useful tools. So once again, thanks everybody for being here. And we hope to see you in future chapter talks. And thanks, Vincent, again, for this wonderful tutorial, and Rosanna for orchestrating all the and managing the chat down there. Appreciate it. All right, everybody, have a great day, and see you next time. Bye.
Thanks. Bye-bye.
Bye-bye. Thank you.
Thank you very much.
Thank you very much.
Thank you, everybody. Bye-bye.
Thank you. Bye.
Thank you.